just go? Or do I wait for them? Just start talking. Okay. Good morning. Welcome to our session, Polar Oceans Extremes as Evidence for Urgent Action. Thank you so much to everyone here in the room for being here at this wonderfully early hour. And thank you to everyone joining online. It's hopefully this will be a really interesting session. We're here today to discuss some of the latest science, but also hear from a number of people that work on that policy-science interface and really discuss how we can get these new evidence for extreme events and extreme conditions that are going on in the polar oceans, how they're linked to the cryosphere and the wider global oceans, how we can think about getting that latest science into the negotiating table much more rapidly than perhaps the IPCC process to date has allowed. And so hearing from our wonderful panel here today, a little bit of the science that's going on, a little bit of the activities that the various members here are involved in, and hopefully we can discuss why this issue is so important for negotiations and moving forward as to how we can get this latest urgent information on the science into these discussions. So without further ado, I will just introduce our panel. We're going to have each of the panel members talk for about 5 minutes, each to their own topic, and then we'll have a more of a discussion after that, followed by a bit of an open session if we've got questions on the floor. So I'm joined here today by Rolf Rodeven, who is the Executive Secretary of the Arctic Monitoring and Assessment Programme, which is a working group to the Arctic Council. I've got a nice picture somewhere. There's me. There we go. And then next to Rolf is Martin Siegert, who is at the Vice President and Deputy Vice Chancellor of the Cornwall campus for the University of Exeter. And he is an expert on glaciology, I believe. Got that right?
Thank you.
And then we're followed by Martin Sommerkorn, who's the Head of Conservation for the World Wild Fund for Nature Arctic Programme. And Martin was also a lead author for several Arctic Council assessments and the Polar Regions chapter for the IPCC Special Report on the Oceans and Cryosphere in a Changing Climate. We have Louis Chemens, who is the youth delegate for the Inuit Circumpolar Council and has a number of different activities within that, who's also a master's student at the University of Greenland. So very happy to have you here. And finally, at the end, we have Pam Pearson, who is the director and founder of the International Cryosphere Climate Initiative. I always get those two mixed around. And she's got a very busy day, so really appreciative of you being here today. And is working on very much in that negotiator science, bringing the science policy together. So I will hand over, first of all, to Rolf to have your 5 minutes. Thank you.
Thank you, Helen, and thank you so much for inviting me to this panel. And good morning, everyone. I'm very happy to see you here 8 in the morning. Well, I guess I'll start just saying a bit about who we are. So the Arctic Monitoring and Assessment Programme is, we were established in 1991, so we've been monitoring and assessing the full Arctic region when it comes to contaminants and contaminants and climate change since 1991. And since 1996, we've been organized as a working group to the Arctic Council. So what do we do? Well, we do monitor the levels and trends of contaminants in all compartments of the Arctic. We also monitor and assess climate change and how both of them affects ecosystems, including socio-ecological systems, which also includes humans living in the Arctic, how it affects health, for instance, and how all these effects work together in a multi-stressor way. So we do scientific assessments of that, peer-reviewed scientific assessments. Those are condensed down to summary for policymakers delivered to the foreign ministers every second year at the Arctic ministerial meetings. But also, for us, more importantly, we feed them into international regulatory mechanisms like the Minamata Convention, Stockholm Convention, and also IPCC when it comes to climate change. So we kind of try to bring the science into policy making in that sense. And well, we also had some successful stories, like, for instance, the Minamata Convention regulating mercury was established due to Arctic data, where we were able to show how long-range transport of mercury ends up in humans living in the Arctic to levels where it had health concern. And I guess that brings me to my next point when it comes to the Arctic. So for us, it's always been important to consider also the people living in the Arctic, because we have to remember that the Arctic is not just a white, empty space. There are people living in the Arctic. There are about 7 million people living in the Arctic, and more than 40 ethnical groups. Almost 10% of the population belongs to an ethnical group. A lot of them, like 3/4 of them, live in larger settlements, that is, settlements more than 5,000 inhabitants. However, most of the settlements are small. So the Arctic, as we know it from the European side, is not very typical for the Arctic as such. Most of the settlements are less than 5,000 inhabitants, and 90% of them are like that. And it may not sound, at first step, it may not sound important for when we talk about oceans, but 70% of settlements are on permafrost, and well, 70% of Russia is on permafrost, and that does also have effects for oceans when it comes to contaminants. So what does our assessments say when it comes to the change we see in the Arctic? Well, we stated in our latest climate report from 2021 that the Arctic is warming 3 times as fast as global average. Other reports have stated 4 times as fast later. However, the conclusion is the Arctic is warming very much faster than the global average, I guess. So we've seen that in average, since 1971, the temperature has increased by 3.1 degrees. That is just the general picture, but we have areas like the northeastern Barents Sea, where we already had an increase of 6 to 8 degrees Celsius, which kind of put the 1.5 target into perspective. So we're already several times 1.5 up there. The precipitation have increased by almost 10%. Most of the precipitation is now taking place as rain rather than snow. So we have 24% more rain and 21% less snow than we had. And at the same time, there's a massive loss of land ice, particularly from Greenland Glacier. Since 2000, the Greenland Glacier have lost about 5,000 gigatons of ice. This may sound trivial when it comes to oceans, but it's not, because these are important sources for fresh waters running into oceans. And as you know very well, Helen, bringing fresh water into the ocean lower the pH, so it turns it more acidic, which severely impacts organisms living in the Arctic oceans. Also, since 1978, the sea ice extent has almost halved. So we lost 43% of the sea ice in September, measured in September. That equals an area about 3.1 million square kilometers. That's an area the size of India. So we lost India since 1978. And again, that kind of brings in tremendous changes into the ocean. So it brings the heat into the ocean. We see species displacement. We see a total change of the ecosystems where Atlantic species are coming up to the ocean. And that is not only just bringing in more species, but it changes the way the ecosystem function by changing the modularity of the ecosystems as such, or how perturbations may flow through the system. So I guess that's where I'm going to stop by now. So thanks.
That's great, thank you. If I pass that along.
Thank you, Helen, and thank you all. So hi, I'm Martin Siegert, and as said, I at the University of Exeter. Another role that I have is to chair the UK's Arctic and Antarctic Partnerships Committee, and pertinent to this session, one of the members on that committee comes from the UK's Foreign, Commonwealth and Development Office. So we have UK engagement, government engagement at that committee. And every now and again, the FCDO sets a question to the committee, which comprises scientists from all over the UK, full variety of different things, all related to the polar regions. And, as scientists, we like to think that we're doing interesting work and everyone should know about the stuff that we do. But sometimes when a government official asks you to do something, it's either, it's like it's obvious, or, why are they asking this a stupid question? But if they don't know it, there's a reason they don't know it, and that's because we haven't done a very good job in explaining it. So we get this sort of question from time to time, and the question set to us last January was, is Antarctica subject to extreme events? And you may have your own opinions on that. So the committee set to it. I think the reason they asked is because in January this year, there was a lot of snowfall in the Antarctic Peninsula, a huge amount of snowfall, and so we said about it. But of course, as 2023 went on, it became obvious that Antarctica was subject to extreme events, and I'll tell you about that in a minute. So I'm going to pick out three elements of the paper. The paper's there, published in totally open access, Frontiers in Environmental Science. You can check it out. Called Antarctic Extreme Events. Okay, so the first element to talk about is, does Antarctica receive heat waves? And of course it really does. So in March 2022, that's a year and a half ago, a huge jet of warm air rushed from Australia, essentially, all the way across the Southern Ocean and onto the Antarctic continent. Really unusual to do that, because ordinarily it's the polar vortex, which circulates clockwise around Antarctica, prevents that sort of activity. But it happened, and it was staggering in size. So in East Antarctica at Dome Sea, where the temperature should have been about minus 50 degrees centigrade, it was more like minus 12. 38 degrees centigrade difference from the normal. That's the largest ever heat wave ever recorded on our planet. And if it had been in the summertime, goodness me, there could have been some melting going on in the centre of East Antarctica, which is totally unprecedented. So yes, Antarctica can receive that. We haven't done the attribution of that work, basically because the meteorological stations are very sparse around there. But another heat wave, the hottest temperature ever recorded in the Antarctic continent, 18.6 degrees in 2020, that has been attributed to burning of fossil fuels. And so we suspect that this heat wave too was also the case. Sea ice, good in the oceans, the reduction in sea ice around Antarctica this year has been absolutely staggering. Since June, and every month since June, it's been the lowest ever recorded, with one exception just a few weeks ago, but I'll come to that in a second. So I was asked by a parliamentarian just the other day, in acreage, how much ice has been lost this year that ordinarily should have been there? And actually, I didn't really have a very good answer. And again, that's another example of, I should have known straight away how much size. Anyway, so I've done the numbers and I can tell you about it. So we've lost month to month. So ordinarily, what would an October look like, and what did October in 2023 look like? And the difference is around about 2.5 million cubic kilometres of ocean surface that should have been covered by ice that wasn't. And so just to put that into a perspective, the United Kingdom surface area is about 250,000 square kilometres. So that's like 10 times UK's that should have been covered by ice, that should be reflecting the sun's solar energy as it comes back in the summertime, but instead is being absorbed because the ocean's now bare and it doesn't have sea ice anymore. Now, a few weeks ago, the 2016 sea ice record, which was also really low, was less than in 2023. So that record was sort of broken, but unfortunately, 2023's come back, and just the last few days, it is now once again the lowest on record. So even beating 2016, which is absolutely staggering. Final thing to say is the ocean is interfaced against the massive Antarctic ice sheet by these huge floating slabs of ice called ice shelves. And you might have heard about Larsen A and Larsen B ice shelves, which disintegrated over a matter of days some years ago. We're particularly concerned about the state of health of a number of ice shelves around Antarctica. And why is that important for the ocean? Well, these ice shelves provide a back force to stop the ice, the grounded ice, from flowing into the ocean. So you don't need to melt the ice to cause sea level rise. You just need to flow it from the land into the ocean. It displaces its weight in water after Archimedes' principle, and that's it. The sea level has happened. It could take 10,000 years to melt. It doesn't matter. And so if the ice shelves disintegrate, accelerated flow of grounded ice into the ocean could really cause more sea level rise. And we're particularly worried about the state of health of that around Antarctica and the potential for a metre, maybe more than that, depending on which carbon pathway we're on in this coming century. So that's why the FCDO is interested in our work, because it really matters to British work and to government decisions. Thank you, Helen.
Brilliant. Very sobering numbers there, Martin. If you skip a few... Yeah, that's it. Perfect.
All right, thank you. And yes, I'm going to pick up pretty much where Rolf left it off with the Arctic Ocean and the warming. And we heard that the global ocean is warming and the Arctic Ocean is warming even faster. And I've picked two topics to show why that is actually significant and should be heard here more at the COP28. I think there are two big topics, sea ice and ocean acidification in the Arctic, that allow us to talk about the need for short-term action, the need because also we will experience otherwise long-term substantial thresholds and feedbacks to the global system, and it allows us also to talk not only about warming but also about atmospheric carbon dioxide concentrations. So first, maybe I should say the Arctic has served a cooling role in the climate system for almost continuously for at least the past 125,000 years. And on this slide here, I'm comparing summer sea ice in the 1980s with now, and we will see that the thickness distribution, it tells us that the system has already transformed to a completely new state. The former ecosystem of multi-year sea ice doesn't exist any longer. Instead, more than 3/4 of the Arctic sea ice now consists of first-year ice that is largely melting each summer, and the older sea ice now exists for only 1 to 3 years on average. So we have a much more dynamic system, one that is much more vulnerable to every 1/10 of a degree of more warming, and it has huge effects as it actually then, when it's ice-free in the summer, absorbs so much more heat and feeds back to the global system. And the reason why we see that this older ice is actually gone, and what the news and that it spends less, that ice spends so much less time in the Arctic, is a lower production of ice. So we have much less ice produced each winter because the season of ice production is getting shorter and shorter. We have this ice actually spending fewer time in the Arctic Ocean, which it would otherwise had taken to build multi-year ice. And it's also faster exported through the Fram Strait east of Greenland, and that is an indication of how much vulnerable it actually gets to being moved around by wind and the changing weather patterns that we also see coming to the Arctic. So this slide is basically there to tell about the story about that only very low emissions pathways preserve summer sea ice, and they also only do just. We see that the very left graph here is the very low emission scenario, and only there do we see that summer sea ice can be preserved in the second half of this century. The first ice-free ocean, the first ice-free ocean in Arctic summer will be an event that the Arctic has likely not experienced since at least the spike in warming that occurred at the end of the period about 8,000 years ago, and possibly not until the period 125,000 years ago, the so-called Eemian period. And temperatures today are nearing those of the Eemian. So we are actually in very vulnerable conditions here. This near complete loss of summer sea ice is now projected to occur at least once before 2050, and only the very low emission scenarios will actually about stabilize sea ice in the second part of this century, but only just. We don't know exactly, but around 1.7 degrees we will face a threshold that sea ice will actually not be there continuously. Below that, warming below that may actually have occasionally sea ice during summers. So that has huge implications for the climate system. And because we are losing the main service of Arctic sea ice, which is basically cooling our climate. Very low emission scenarios. We will see sea ice in the summer probably coming back, and if we further reduce temperatures back to below 1.5, we might actually see that there will be another build-up of multi-year ice in the future, but it will take decades and even longer because to rebuild that system, even under those conditions, because the Arctic Ocean is warming fast and will continue to do that for a while. The second topic I'm briefly coming to is ocean acidification. And this graph, that dropped off the slide here, is actually from the IPCC Special Report on Oceans and Cryosphere in 2019. The Arctic and Southern Oceans are bearing the brunt of acidification impacts because they absorb CO2 faster, because colder and fresher waters can hold more carbon. And they have absorbed the lion's share of this dissolved CO2. And by some estimates, actually, both polar oceans together have absorbed about 60% of the carbon that we have emitted into the atmosphere. A huge service slowing down global warming, but it comes at a hefty, hefty price. And the hefty price is that the ocean acidification. And what we're seeing here is the difference between the acidification levels in a 1.5 degree world on the left and a 3 to 4 degree world on the right by 2100. So the red shows undersaturated aragonite concentrations, which is a measure of ocean acidification, meaning that shelled organisms at the bottom of the food chain will have difficulties building or maintaining their shells, and that leads to potential decline of populations, dietary sources for fish, and loss of the biodiversity, complete revamping of Arctic and Antarctic food webs. The Arctic Ocean, however, appears to be the most sensitive. Already today, it has large regions of persistent corrosive waters. And this is important because the rates of acidification today are faster than at any point in the past 300 million years. And that is far too quickly to let organisms actually evolve, adapt, or survive. There is no other way than to fight ocean acidification than to control atmospheric carbon dioxide concentration. And anything we do and postpone will have large effects, because the removal process, that are the geophysical removal processes of acidification, they only work on very long time scales. So it takes basically thousands of years to remove those. So the last thing that I want to mention is that only very low emission pathways keep Arctic Ocean Arctic Ocean waters above year-round corrosive levels. As you can clearly see in the graph here, only the blue line actually stays across the threshold, where on average the year-round corrosive levels are not exaggerated. So very low emission pathways will limit corrosive stressing conditions to mostly seasonal damage, which allows repair by those organisms potentially. And you see the effects on one of the most dominant organisms, the pteropods, the shells on the right-hand side with corrosive conditions for their shells. So harmful impacts at the lower end of the marine food chain will cascade towards higher ends of the food chain, and this is important because we have about 4 of the world's largest fisheries happening in and around the Arctic Ocean, and this brings millions of seafood meals to people in the Northern Hemisphere. I'm stopping there.
Thanks, Martin. Really good summary there. And if you want to hear more about acidification, I'm just going to plug the AMAP talk later on when I'll be talking more about that.
Hello. So first of all, thank you for giving me the space as a youth delegate to present and speak at this space and share an important perspective. You mentioned in the beginning that it's important to acquire the latest science and use that. And then I'd like to thank Rolf for mentioning that there are people living in the Arctic, and people have lived there for long. And then, of course, it's important to use new science, but also really take advantage of the unique knowledge that we have of the Arctic that we've had for centuries. So I'm here representing Inuit Circumpolar Council, which was established in 1977, and I'd like to share a few of the perspectives. So just a few words on the indigenous knowledge and the Inuit take on the ecosystem. So we see that the ecosystem is, it's our home, and we share the home with many other living things, and we are an integral part in this cycle. So our knowledge also expands, is expansive, and is not only on certain small things, but we see that this picture you see in front of you, often we also share it as a puzzle pieces, and that every piece makes up the whole picture. And we see therefore the connections between all the parts, which I think is very important, that we often see in Western science where we zoom in on certain things, but then understanding how everything is interrelated is also a very important part to think of. So the Inuit Circumpolar Council has presented a equitable and ethical engagement protocol. And in that, they refer to UNDRIP, the United Nations Declaration on the Rights of Indigenous Peoples, where they say that UNDRIP affirms the Inuit right to engage in governance of all things related to us and our lands, territories, and resources, which I think, of course, is very important to share when engaging in the Arctic. And then just a few words on our understanding of conservation. Conservation can mean many things for many people, but for us, one important thing is that conservation for us is through use. So we see ourselves part of the environment, and by conservation through use, we can also withhold, we can keep that knowledge that we have and further use it and develop it. So conservation is more than just protecting certain species. For indigenous people, it's also a lot about sovereignty. It's about food sovereignty. It's about the rights of being the people that we are and having the culture that we do. So what we see often is that, indigenous communities kind of share the burden of what conservation often tends to be explained as. And we see that conservation can be imposed on Inuits, on indigenous peoples, being told how they should understand or how they should practice conservation. So that's one kind of burden. And another kind of burden is also that we are really out there in the field and we are monitoring and living in that nature that we all care about. And then we have these no-take areas that can violate indigenous peoples and their rights. We see, for example, bans on whaling and other things. And I think it's just important to include the Inuits and that it shouldn't be on the cost of people, indigenous peoples. Just a few words on Olsvig. So this is the largest polynya in the Arctic, between northwest Greenland, Olsvig, and Nunavut in Canada. And it's ice-free all year round due to water currents and wind. And it's biologically one of the most productive areas and has a historical significance to Inuit. there was a letter of intent signed by the government of Greenland and the government of Canada in October that I know ICC also really applauds. It serves to this is really an example of Inuit marine management and marine governance. And I think through this we're finding new ways of doing things beyond national jurisdictions. And we also know that the climate change does not care about national jurisdictions. So, yeah, I think that's what I'd like to share to begin with. Thank you.
That's really, really great. Thank you. So finally we have Pam. I think if you just...
Don't have a presentation.
You can
Thank you. And
press it once,
I
just
think that it's highly appropriate that I am following you as both a youth and a representative of the Inuit Circumpolar Council. Sometimes I feel ancient in these because my negotiation experience within government goes back to Kyoto. So that's pushing 30 years right now, probably before you were born. And yet I can tell you that Inuit and Sami have been coming to these climate negotiations all of these decades with the same message. And it still has not been heard. That these places are changing, that it is having impacts, and what our role organizationally has tried to be is to translate the science, like we heard from Martin Sommerkorn, from Martin Siegert, and also from Rolf, for negotiators to make it clear that what is happening in the Arctic has implications throughout the planet. And I would say that in some ways the implications are greatest for those living in the Arctic and who've been living there for tens of thousands of years, and also for those who are living in the small island developing states and in low-lying areas who have no ice and snow, but are being impacted by things like sea level rise, or being impacted by loss of glaciers and snow. So they have loss of water resources, or they have saltwater incursion that they're dealing with that makes it impossible to continue with agriculture. And so what is happening in cryosphere and snow and ice regions has implications throughout the planet. And the biggest aspect of this that probably especially goes for polar ocean acidification, but really all of these, is that they're irreversible on human timescales. You know, once an ice sheet really starts to melt, which we're beginning to see in West Antarctica and in Greenland, it continues melting for centuries to thousands of years. If we overshoot 1.5, or even if we overshoot, frankly, today, you know, you can consider today, it's an anomaly in the Earth system, and we're already seeing the ice responding to the level of CO2, which, you know, it must be said, it is now 50% higher than pre-industrial. This is just unprecedented for 3-4 million years right now. It's going to continue to melt for hundreds to thousands of years. There's a certain level of sea level rise locked in. Once a glacier disappears, the latest research says it's going to take hundreds to thousands of years to come back. And so those water resources are gone for the downstream and mountain communities that rely on them. Ocean acidification is 30 to 70,000 years. That's about as permanent as it gets, especially in our puny human brains. So this is something that really should be injecting urgency into these negotiations, especially in the global stocktake, because how can we take stock of how adequate our efforts under Paris are without taking into account these kinds of changes that are permanent and lasting, that humans and ecosystems will need to live with for hundreds to thousands of years. So that is, you know, one of the ways we're trying to do this is actually our very first ever scientist, so far as I know, you know, we're doing a demonstration, which, how much does it take to get scientists to jump up and down and say, pay attention to us? So that'll be taking place at 10 today. And then on the sort of higher political level, Ambition on Melting Ice, which was formed last year in Egypt, is going to be meeting. 2 of its founding members were Vanuatu and Samoa, in addition to Iceland and Norway. So that's sort of the message, that what happens in these regions, one often hears what happens in the Arctic doesn't stay in the Arctic. What happens in Cryosphere doesn't stay in Cryosphere. That is a really important message during the stocktake, and we hope it will be heard. We hope that, the voices of the Inuit that have been saying this really for 30 years now will finally be heard in these rooms. So thank you.
Thank you, Pam. And I think it's been a really nice discussion about the latest science that we've heard about, but also then starting to think about how we're getting that message across through the different policies and working with Indigenous communities. So I have a few questions that we would like to discuss before we open it up to the floor, to just continue that discussion a little bit more. So I'll actually start with Martin Siegert, if I may. So we've heard a lot about the new science and evidence. Do you think there's enough high-level government understanding? I mean, you talked about the work with the UK that they're doing with the policy. Do you think there's enough understanding of the importance, particularly of the ocean and polar oceans, in this kind of global uptake of heat and carbon, and what does that mean? What that means for loss of ice and glaciers and things, but actually for the wider community, for the wider global planetary cycles?
Yeah, it's a good question. I think the first thing to mention is that when we're referring to the polar regions, these are the most poorly understood, unexplored parts of our planet, and for anyone to think we've got a good handle, really good handle on what's going on, right? They'll be misleading you. So we have some good ideas about what's happening, and they're frightening. And what we're seeing in recent years is an acceleration of the changes. So as Rolf was saying, the Arctic is warming at 4 times the rate of the rest of the planet, and the Antarctic is starting to show similar sign, about twice the rate of the rest of the planet. So when we're talking about the unabated emissions and 3 or 4 degrees centigrade, what that would mean for the Arctic would be a catastrophe. And so from the UK's perspective, for example, what does that mean? Well, actually, an awful lot. The UK receives its weather from 6 classic systems. 4 of them involve the Arctic. So when the Arctic changes, the UK's weather, which is quite an unusual weather arrangement that we're having at the moment, it will change as well. So it's not just about global sea level. Well, that's bad enough. Right? It's not just about heat exchange around the planet. It's just as simple as weather. And the same is true of lots of other places as well. So is that really understood? Well, no, it isn't, because we had to write a paper just on that measure alone to hammer that point home to politicians that this isn't a distant land and something happening there, don't worry about it. It will affect us, sure, in global sea level rise, but it affects us in more profound ways. And everybody living in the United Kingdom will feel the consequences of what's going on in the Arctic and probably the Antarctic as well. So that is not fully understood by policymakers. It needs to do so, and of course being here can help, but we've got to continually put that message. I would say that the UK Arctic and Antarctic Partnerships Committee is a particularly good forum to have that exchange, and if we have any countries that don't have a similar forum to that, get one, because it's a really good way to test out whether government officials really understand the science, and vice versa. Questions on their mind, are you responding to those questions in an appropriate way? So if you haven't got one, please do set one up.
Thank you. Yeah, that's a really good point. It's even just simple things that we see day to day, which leads back to perhaps Pam and Martin and Rolf, if you fancy, but pass you to Pam first. So we are hearing this new science, and we've worked with you for the ICCI and various processes that you have. But so this new science is coming up much more rapidly than the IPCC reports, and that's kind of generally what a lot of negotiators fall back on, is these big reports that come out every 6-7 years or something. So what's the ICCI doing? What is the other processes that we can perhaps use to get that knowledge in more rapidly into these processes, into the negotiating discussions?
Well, we started with this, by doing side events like this when there weren't, all these pavilions, et cetera, et cetera. Every year at COPs, every year at the Bonn Intercessionals. But things are changing so quickly, both in terms of observations and projections and the sophistication of models that are being used, that we felt it was necessary to begin putting out actual annual updates of cryosphere science, precisely so that this could reach to policymakers. I can pull out my copy of the State of the Cryosphere report. It was released here last week. But that is our bit, in a way, in sort of policymaker-friendly language, very briefly, to both have basic background on these dynamics and how they work and why they're important every year. And that doesn't change a lot. But then updating also the latest science over that past year. What are the key findings? What are the key observations? What are the key new studies? And two of them, one of them you actually saw on the screen from Martin, which is a very elegant way of looking at sea ice that sort of said that the only emissions pathway that preserves Arctic sea ice above what is called, zero summer levels, essentially ice-free, is the very lowest emissions pathway that we're very close to exceeding right now. As a matter of fact, I hate to say this, but that pathway, that specific pathway that we refer to, I found out a couple of weeks ago is no longer feasible. So SSP 1.9 is no longer feasible. However, the good news is that there are other SSP1 pathways, because that's just one of several, that can still keep us to this one. It's actually a 1.6 level, brief overshoot up to 1.6, and then below 1.5 by the end of the century. So there are other pathways, but we've lost one of them. That's a really important message. And so these are the kinds of things that are really important to put forward to policymakers, both when we lose and yet that the option is still there. We really are making a decision to make these things happen. They're not inevitable. We're deciding to do so, and we need to accept that.
Absolutely. Martin?
Yeah, I would like to add a dimension to that, and that is going back to the IPCC. We can do these things, and they're hugely helpful, like updating the cryosphere science, having our voices heard, jumping up and down, as you put it, Pam. I think that's needed in this kind of fast emerging science field, especially for the polar regions, and its significance for weather, for climate, for food security, for all sorts of things, for impact on the people in the region. But I want to add 2 points. One is the IPCC. I think, in my experience, the UNFCCC is still in need of credible, united assessments, authoritative assessments. And you will see that the references they make in their policy making are actually mostly with reference to the IPCC. They not really dare to put in any references for single papers, single initiatives, etc. So there is a process where the IPCC thinks how it can actually do more and better. More is difficult because scientists are already kind of up to here in their commitments to IPCC reports. But different might be something that is important to recognize here. More topical and special reports that actually target the questions of the day, the political questions of the day. That is an important thing to consider. And secondly, I would personally say there is a huge need to synchronize, in a way, the products of the IPCC with the political processes at the UNFCCC. So, for example, the 1.5 special report should have come, ideally, updated and fully authoritative at the point of the GST now. Those sorts of synchronizations, I think, are very important to think about for the IPCC.
Brilliant, yeah, thank you. Do you want to comment, or if you've got... Yeah.
I can do, yeah, thanks. I mean, in 2018, we saw this happening. We saw the change of the Arctic speed at such a high speed that we needed to speed up as well to be in pace with the Arctic warming. So we decided to go from assessment reports taking place every 7th year to every 2nd year, because we do see that observation models are developing so fast that we need to do something. And for us, it's a way to actually facilitate, feed in data from the Arctic to IPCC and to UNFCCC and other organs to try to help off on this topic. Also, like I said here, I would like to see, what we see is really useful is to connect closely policymakers and scientists actually to be able to communicate this. So even though, I really like to see you here in the audience, but I would really like to see the empty chairs filled up with policymakers to be able to discuss, to find a policy relevant question, to see how also science can be more targeted on those questions needed to be answered, just as you mentioned earlier. So thanks.
Yeah, it's a good point. We're talking to the converted sometimes when we have these discussions. So, Louis, if I can come to you, we hear, we need this indigenous perspective, and particularly for the Arctic Ocean, it's imperative that we try and integrate that knowledge. There's a lot we can learn from indigenous leadership. So can you perhaps share some more information about the Arctic conservation efforts that Inuit are leading, and how Inuit researchers and governments could better work together on realizing these priorities?
Yeah, I think I'd like to go back to the Pikiles Olsvig. I think that's one of the most recent and good examples of an initiative by the ICC. It was Inuit-led, and it's sort of a new way of doing things internationally, I think. And I think what is also important is to go to Inuit leaders in order to understand how to use indigenous people's knowledge, and sort of be guided by Inuit leaders to really understand what role it takes. I think we have the right to share how we want to and what we want to. So I think that's a really important aspect. So I think it is important that we collaborate, but we also do that crucially from the beginning when addressing certain things, that it's not an already defined objective there is, that then you add sort of an indigenous perspective to that, but really that we together try to find what is really our objective. So it's important to really understand the situation of the Arctic when engaging in the Arctic, and of course the people there are there to help. And so referring to the protocols of the EEE protocols, I think these are examples that are really important to engage in and to understand, and they kind of show us a guide to how to work in the Arctic with the Arctic indigenous peoples. That also helps to understand that it's important to have the respect and understanding of Inuit values, and see the importance of establishing the relationships and building trust with the indigenous peoples. And I'd like to share quotes from former ICC Greenland president and also Prime Minister of Greenland, which is quoted in the EEE protocols, where he says that we know from experience that it is always beneficial to all involved to treat each other with the belief that we are all people and all equal, and that we all want to contribute to a better world for all. Thank you.
Thank you. I've just been told we've only got 5 minutes left. I thought we had a bit longer, but are there any questions from the audience? Yeah, go out to the audience quickly.
Well, thank you so much to everyone. It was quite interesting, and I think it's urgent to have these discussions, not just here, but everywhere, in every spot that we can find in this place. But my question goes to you, Louis. It is amazing and quite encouraging to see you here in this kind of discussions. But my question is referred to as well Martin Siegert, that we know that we're doing something perhaps not very well in terms of communicating what is going on. So from your perspective, what do you think that we as part of a Western science perspective, we are failing at communicating this urgency? And how do you think that your wisdom on the connectedness of the world can help really rise this urgency?
One of the first things I think of is how we mentioned that the Arctic is warming 4 times faster. And we sort of have this 1.5 as the roof. But understanding the importance of the Arctic and seeing that has already risen 2.2 degrees Celsius since pre-industrial time really shows us that this kind of statistical average does not really work. We see how the acidity and the warming and the changing of the ice sheets, we are above the 1.5 in the Arctics, and kind of saying that we, on a global scale, have not reached that, while the most important areas are already above that point, I think is a really important message to bring. And I think that everyone should try to refer to the Inuit leaders and learn from that and engage in some of the work in order to get that better understanding. And I think it's limited what I can say as a youth delegate, but I know that there's a lot of amazing indigenous leaders that have done amazing work and that should really be valued and used by Western science. Yeah.
Do you want to add anything to that?
Oh, well, very briefly, but just on sea level, if you wish. So there's been a lot of discussion, a lot of research on sea level going into 2100 and after that, and I think we underplay it, and we need to change the narrative. So look at the IPCC, and the words will be something like, under a strong emissions future, there's a likelihood of it being somewhere between 50 centimetres and a metre. Likelihood. Well, that's IPCC speak for saying it's 66% chance lying in that range. It's not going to be less than 50 centimetres under a high emission scenario, which means there's a 1 in 3 chance it will be more than a metre. And when you ask glaciologists what is possible, not what is likely, but what is possible, they'll say 2 metres, maybe 3 metres this century under a high emission scenario. It doesn't stop at 2100, as Pam was saying. Sea level keeps going. And by 2150, it could be 3 to 5 metres. You know, could be, right? Well, if it's 3 to 5 metres, that's the end of quite a few countries on the planet, including the Netherlands, by the way. So why aren't we talking about this in this term so seriously? We're just not. And so Pam's efforts to raise the profile of this have been astounding, and I'm glad we're going to take a more proactive, demonstrative approach in an hour or two, because I think we need to, because clearly it's so obvious that this message needs to get out, and for some reason, I don't understand why, it just hasn't resonated in the way that it should do. So time for us to change tactics a bit.
Thank you. Did you want to comment?
Yeah, I just want to specify that the reason we're trying to raise this is ironically or maybe serendipitously the 10-meter line, which has been used, runs straight through the center of this COP. So we're going to be showing where that would be, maybe with a bit of humor. But, you know, that's the kind of future we may be locking in, because ice sheets have done this in the past, and they may be able to do so again.
Final word to Martin.
Just two very quick points. I think the first one is there hasn't been, despite very, very good efforts by ICC, Sami Council, some country representatives, there hasn't been such a unified voice from the Arctic as we have seen it, for example, from the small island developing states. So there is a real still potential to come to that and to use it in that way. So that's the first thing I want to say. The second thing is that we actually have been working hard and have had traction in the aftermath of the IPCC Special Report on Ocean and Cryosphere to establish something at the UNFCCC that is now called the Ocean Climate Dialogue. but it's all about solutions. It's not about impacts, because nobody wants to be active on impacts, and it is very hard to get active on impact, but everybody, or more, actually can get active on solutions. Now, that means that there is also a way to come to solutions and maybe then come back to impacts. So there is another way of actually getting to the point, and we shouldn't leave that untried. Thanks.
Absolutely, thank you. I think we probably don't have time for much more, but maybe if I could just have one quick sentence from each of you to finish up on why polar oceans are this urgent, provide this urgent demand for action. If I can just have one final end to this session. Okay.
I guess it's obvious from this presentation, 1.5 degree scenario is the only one saving the ice cap on the polar ocean, which is kind of the blanket that has allowed us to sleep calmly for the last thousands of years. Removing that increases the warming of the Arctic, increases the glacier melt, increases the acidification, increases the sea level rise, disturbs the weather connection systems, and in that sense, we will all become Arctic inhabitants. Thanks.
Yeah, the polar regions are the most beautiful, still pristine in some places, but less so, places on our planet. And we must absolutely do our level best to keep them that way.
Yes, awe is a huge motivator. I think we should more of it. But the global consequences of the polar oceans changing are huge, and we must use the course correction that we can do right now in order to act. Yeah, I'll leave it at that.
The oceans have always been an integral part of indigenous peoples, and still is today on a broad level as peoples, as identity, also economically, of course. And we have a unique knowledge about it and cares about it and knows the importance of keeping that safe. And we know how important role it plays in the overall global climate change.
Awe is good. This is the 2023 State of the Cryosphere report. We put, nice pictures on here, pretty pictures, because these are awe-inspiring places. These are actually photos by scientists always. But my final word would be that the ice and the polar oceans especially doesn't care in terms of what we are talking about in negotiations on one level. All it cares about is the level of CO2 in the atmosphere, and that's what we need to address.
Fantastic. Well, if you join me in thanking the panelists, I think that was a really interesting discussion today. And if you're interested in more Cryosphere, polar ocean stuff, there is several events today. If you pop up to the Cryosphere Pavilion, which is just upstairs, then you can find out more. But thank you very much for everyone attending.